Hello, we are Team 8, and welcome to our presentation on information retrieval. This is our table of contents. Rapid advancements in AI have led to massive changes in industries. Public sentiments are polarized regarding its impact on the job market. Social media data is vast, unstructured, and noisy, which makes it difficult for policymakers, businesses, and job seekers to make sense of all of these sentiments to make informed decisions. Hence, our solution is to develop an advanced search engine to deliver actionable, granular understanding of AI's perceived impact on employment. This is our overall system architecture.
So, to start off, we built our corpus by crawling over 13,500 posts from Reddit, Twitter, and LinkedIn, the three of the most opinionated platforms for public discourse on jobs and AI. We use APIs, Selenium, and cosine-based filtering to capture only the most relevant and high-signal posts. Once scraped, we pre-processed each post by cleaning, timestamping, and extracting metadata like engagement and platform source. This gave us a structure-ready JSON dataset. Then came the three-stage NLP pipeline. First, we filtered the semantic relevance using SentenceBird. Next, we annotated sentiment and subjectivity using TextBlob. Finally, we used zero-shot classification with AI masking to assign each post up to 5 industry tags. But we didn't stop there. We ran deeper classification layers. We added NER to extract entities like companies or job titles, concept extraction to map out themes like automation or mental health, and finally, aspect extraction to surface the exact noun phrases users were reaching out to, making the data dashboard ready.
For indexing and querying, we store our crop corpus in Apache Solr, which allows efficient data retrieval. When a user submits a query from the front end, the back end sends an API request to Solr based on the input, retrieves the relevant results, and displays them on the front end. We have included several innovations to customize the search result. Firstly, timeline search, where users can search results based on the document post dates. Secondly, is categorical search. There are 18 possible categories to choose from, ranging from technological and IT, finance, education, and many more. Thirdly, multifaceted search provides user a wide range of other possible filters such as popularity, polarity, sources, and ability to sort by dates and popularity. Lastly, enhanced search. It is possible to view plots generated based on the search result by clicking Show Graph button, generating plots such as word cloud, polarity, composition, sentimental distribution by industry, and many more. Here is our search engine. For the input query, we have enabled fuzzy search, which allows it to return results that closely match the query even if there are spelling errors. Users can customize their filter result by date, popularity, and category, and can sort based on the different attributes like popularity. The search engine will then display the relevant result based on the filter. Let me show you the whole process. Let's query the term replacement without a letter E. Date from the start of 2023 to the end of 2024. Popularity from 0 to 100. Sources only from Reddit and Twitter, and contains the category of technology and IT. Then click the search button. A total of 220 results is retrieved. And you can see here, despite me misspelling the word replacement, I can still retrieve the correct spelling result of the query. By clicking the Show Graph button, users can also view the analysis of the returned results such as word cloud, polarity composition, sentimental distribution by industry, and many more.
Now moving on to the overall performance of our datasets. We observed strong inter-annotator agreement confirming dataset reliability, and our random accuracy test showed 84.8% precision and a 75.6% F1 score, indicating good generalization of our dataset. This visual highlights that neural sentiment was predicted most accurately while negative sentiment remained more challenging. Tech and IT post had the highest category accuracy, likely due to the clearer contextual cues available in the data. Lastly, the system processed over 12,000 records efficiently, averaging 9.7 seconds per document with stable scaling and consistent query speeds, making it ideal for real-world deployment.
In social media, users frequently convey sentiments through sarcasm, which conventional sentiment analysis tools may fail to detect. Hence, our first innovation study is to develop a sarcasm-aware classification framework. For this study, we have 3 tested versions. First, the baseline of using literal sentiment analysis model, then in V2, to add polarity along with sentiment analysis as a hybrid model, and lastly, V3, to combine sarcasm detection model with polarity and sentiment. Here are our results. As you can see, V3 performed the best when tested against our evaluation dataset. Therefore, this shows that sarcasm detection is an important aspect when it comes to sentiment analysis.
Now for Innovation Study 2. Social media language is very messy, from emojis to slang like jobocalypse. So, for our domain classification, we moved beyond the brittle keyword matching to a multi-method pipeline. We started off with version 1 with exact lookups, and then layered in fuzzy matching, semantic filtering, and then finally moved to a 3-model zero-shot ensemble. As a result, our F1 score shot up from 48% to 81%, as well as our Jacquard matrix went from 33% to 72%, while still keeping our precision and recall at a very strong level.
Traditional sentiment analysis simplifies posts to just one sentiment, even when people express mixed feelings. Like in this text, AI tools are great, but the job situation is scary. A typical model might call it neutral. But clearly, the sentiment is both positive and negative depending on the topic. To solve this, we use aspect-based sentiment analysis. It breaks the sentence into specific aspects and classifies sentiment for each. So instead of one big label, we know exactly what the sentiment is about: positive for AI tools, negative for jobs. ABSA outperformed traditional methods by aligning with human intuition, revealed mixed or conflicting sentiments, and improved clarity. It outperformed the baseline in 6 out of 10 cases by offering more detail or correcting misclassifications.